We're here. Good, good. So since Carmen did like such a wonderful introduction, I will skip the boring part and cut to the meat. Especially that I'm kind of low on time. So like I owe you two pieces of apology before I start. First of all, when I was like submitting this talk, I was hoping that I can talk about queries and this kind of reactive part. But like I just got too much material for the rendering part, so there will be no reactive part. It's just normal parenting without the reactive part. The other piece of apology is that I've got like really a lot of material and like I've got like a heavy code examples. So if at one point you feel like this dog that kind of gets stuffed more and more and you kind of can't take it anymore, that's exactly the feeling I'm looking for, right? So this will be very nice talk. So the kind of inspiration or the idea for the talk came from this GitHub issue that the gentleman called Born to Net opened a couple of weeks ago and said like, oh, you've got all those wonderful concepts like View or TemplateRef, ElementRef, and like all those APIs, but you don't have great documentation for it. And like we couldn't agree more with the guy. And when I saw this issue, I was like, hey, but I know this stuff because for the last year I was working on those bootstrap directives where you have to go down to those lower level APIs. And while it's true that we don't have like a great documentation for it, those concepts are rather simple. So what I would like to do today is to share, like what I learned about those APIs. It's not only that I was only using those APIs, but I was discussing them with Miško and Tobias extensively. So hopefully this talk will fill the gap till we've got like a wonderful documentation, right? No, I did sound like Igor doesn't approve, so I don't know. Okay, so the word of warning, all the code examples that you are going to see, it's like Angular 2.3, which was happily released just like yesterday, so thanks for this. It's just because there were new APIs added that make things I'm going to talk about much easier. So before we see the code examples, like let's just 2 minutes about the like general theory of everything, like why we are talking about the rendering engine of the framework. And for quite a bit of time, we know that any framework on this planet, or probably in the entire universe, can be described with this one equation, with this one function, right? Like the framework is the function that takes the DOM event and then maps it to the DOM update. So like every framework looks like this. But a few years ago, there was this gentleman coming and saying, who thinks that the previous guy was wrong? Well, maybe not like kind of wrong in a completely screw up kind of way, but like maybe not precise enough, right? So this gentleman said that actually how we could describe or like what we could say about the frameworks that those declarative model-driven UIs are the good thing. This is how we want to construct frameworks. So in fact, we could say that any framework on this planet or in the entire universe can be described as the mapping from the model change to the DOM update. Right? The other thing that this gentleman is claiming is that components with the custom elements are a good thing because it allows us to split UI into kind of more manageable chunks. So when you think about those kind of two things, at the end of the day, every framework today is trying to do two things. First of all, to come up with the syntax that allows us to map model update to the UI update. Like we want to express in a human readable way how the model changes should be reflected in the DOM. And the other problem that you have to solve at the same time is like how to do it in an efficient way, how like to do the DOM updates in a very fast way. So the question is like how Angular solves this problem, how this mapping happens, and like what makes it fast. So let's start with the basics, and the basics in terms of Angular elements. So here's like a very simple component, like example of the very simple component, where you click on a button and the background color of some other element changes. Like there's not much happening here, but still there is some response in the UI to the user action. So in this sense, this component is dynamic, right? I'm clicking and something changes in my UI. But at the same time, this example is extremely static. like if you look at this component, there's no way, like there's physically no way that a new DOM element will be added or removed here, right? So like we can't do anything here. So can we? So we kind of going to build our mental model of the rendering engine. So we've got those elements. Elements can have like model bindings to their properties or attributes, and they can listen to the events. Once again, this is very static model. The question is, can we make this model more dynamic with the directives? Well, so if we look at the rewritten code example that also changes background color as the directive, once again, very contrived example, but we can see that directives are more powerful because they can inject something called element reference, right? So, and this element reference is a wrap around the DOM node at the end of the day. So we can see that the directive like this is more powerful because we've got access to the DOM. So we could go really crazy and be really dynamic and like change this DOM tree in the directive completely. But this is usually not what we want to do. Like we don't want to kind of start doing jQuery here, right? So in the sense, like most of the time, directives are still very static. But once again, it kind of looking at the directives is help us to build our mental model. So we've got elements. We can have directives sitting on an element, and you know that you can have more than one directive sitting on a given element. But also, if you look at the previous code example, you will see that we were injecting something called element reference, right? And this is the element on which the directive is sitting on. So kind of conceptually, I'm not saying it's implemented like this, but conceptually, we could think that each element in Angular has the associated injector, and this injector gives you access to the things that are specific to a given element. Once again, it's not like every element has the injector. It's not like it's implemented, but conceptually, we've got this ability. OK, so the question is, how can we make our application dynamic in the sense of like adding and removing DOM nodes? And probably the example that is the easiest to understand and the most used is ngIf directive, right? Like this is the first moment where we actually adding or removing DOM nodes from the entire application. So what we are going to do is to go a bit crazy and re-implement the ngIf directive. So and Igor, like I see the scary looks in Igor's eyes. It's fine. So let's say that for whatever reason we don't like the built-in ngIf. Because, like, I don't know, it was badly implemented, and we are going to come up with the better version. How can we do this? Well, we know already that we can inject element reference to have access to element on which the directive is sitting on. So somehow, I can get a hand on a template element in the DOM. And it will serve me as the anchoring point, so I know where to insert the dynamic content. Right? So this is this guy. I'm also injecting here something called template reference. So what is template reference? You see that there is the template element, and this template element has some content inside, right? So what the template reference is the data structure or this thing that captures what's inside template element, right? Like the text node here. And it allows me to stamp out later on, right? So like as soon as I've got the access to the template reference, I've got access to the content that is enclosed between the two template elements. And I can grab this content and dynamically insert it one or many times, right? So this is where I can get really dynamic by inserting new stuff. So I hope that you can see those code examples. If not, I tweeted the presentation, so you can follow along on your laptop if you can't see this. But anyway, like as soon as I've got the template reference, inserting DOM nodes, like the chunk, the code fragment that was between the template tags, it's very easy because I can say, hey, template reference, create embedded view. So you probably heard those concepts like view, embedded view. And the view is just, first of all, a bunch of nodes, like, right, that we've got in there. And we've got different types of views. We are going to look at them. But the views created from the template reference, they are called embedded views. So I said that the views are the bunch of nodes. So after we create the view, we can move nodes around to the final position. The last thing I need to do is to call detect changes on the newly created view, right? So once again, like the view is the thing that has the set of nodes that cannot change, like the set of nodes, and it's also kind of context for the change detection, right? And obviously, like ngIf also is destroying views, so destroying things is kind of opposite. I'm destroying the view, I'm removing the nodes, I'm done. Cool. So our mental model is building up. We introduced the concept of the view. And once again, the view in the Angular 2 context is the set of nodes which stay the same. Like they always stick together. Like you cannot insert new DOM nodes. You cannot like remove them. You can insert new views, but you cannot remove or add nodes. We also saw that I can inject the template reference if I'm happening to sitting on the template element. So what we were doing so far, once again, like when we inserted dynamically template reference, like the view created from the template ref, we created the view, we moved the nodes around, and we kind of connected it to the change detection. And this will be the kind of three-step process that we will be following for all the other types of views. But like we kind of did our ngIf implementation the hard way. It turns out that there is another API which is called ViewContainerRef, which allows us to implement things like ngIf in a much easier way. So we know already that we can inject in our directive a template reference. Once again, I can capture the content and I can stamp it out later on. But here I'm injecting something new, which is called ViewContainerRef. So as the name implies, it's the container for the views. It's this kind of logical data structure where I can keep sticking views. I can keep sticking views. And this is how I can make our application dynamic. The interesting part about the ViewContainerRef that it's also anchored at a certain point. So we're saying like in the ViewContainer, I can insert views. But since it's connected to the node, I'm inserting those views in a very precise place. Like it knows where to insert the nodes. Right? So if we use this new ViewContainerRef API, our ngIf or myIf implementation becomes very simple. I'm just saying ViewContainerRef, so this container for the views, create me embedded view from the template reference. Notice that I don't have to move nodes around, because the ViewContainerRef is anchored at a certain point. And I don't have to mess with the change detection because ViewContainerRef does it for me, right? And if you go to the ngIf implementation in the Angular repository, it's not far off from this. Like it's exactly this code, right? So like adding and removing the content dynamically from the template element, it's quite easy. Right, so like we said that we've got these ViewContainerRefs that are anchored on a given element. So when I'm inserting somewhere something, I know where it's going to be inserted. And kind of here we are closing the cycle because we said we've got elements. Elements can have view containers. View containers can have views, and views can have elements, and so on and so on. It goes like this. So we can have the kind of recursive tree. Right? This is how we can actually build a tree in our application. So this was the template, but and obviously re-implementing ngIf might be fun for some people, but actually there are like practical use cases where you want to insert either content from the template, or if you want to insert dynamically content from components. So router does it all the time. It looks at the URL, it looks at the router configuration, and it inserts components dynamically. But there are other use cases like popovers, right? Like I've got this popover, I'm clicking on a button, and I want to insert dynamically the popover window. So let's try to implement it. How to act as the router, how to actually dynamically insert components. Well, first of all, to have something to insert, we need to implement it. So let's implement a component that represents this popover window. It's very simple. It's just a popover window component with a template, all hard-coded, like nothing fancy here. How can we insert this dynamically? So let's say I want to have this popover directive that sits on a button, and when someone clicks, I want to insert component dynamically, once again, as the router does in response to location changes. I know already that I can inject ViewContainerRef, so I can insert views anchored in this button. The question is, how can I get a view from a component? I want to insert component. I've got the ViewContainer that accepts views, but how can I get a view from a component? Well, this is where the component factory resolver comes into place, and this will be the API that allows us to ultimately turn components into views that I can insert dynamically. A word of warning, component factory resolver, like the components that we want to insert dynamically, they need to be listed in the entry components of the ng model. And the way it works is that when compiler goes through all the ng modules, all the templates, and so on, sometimes dynamically, the component that we want to create dynamically might not be used in a template anywhere. So the compiler doesn't know about it, right? So by doing it, like listing it in the entry components, means like, hey, compiler, there is a component that someone might want to insert dynamically, so go and compile it so it's ready for the insertion. So as soon as we get a hand on this component factory resolver, we can do two-step process to turn our component into the view that we can insert dynamically. So first of all, we call resolve component factory from a type. It gives us component factory. And then we can go to ViewContainerRef and say create component. It's all kind of, like there's a bit of ceremony. Those method names are quite long, and like you have to do all those steps. But ultimately, it's a very simple process. The bottom line here is that I can have a component type and turn it into a view that I can insert dynamically, right? And this is what router does. This is what all the kind of type of widgets do as well. So destroying things is also like very simple. I can kind of call destroy on what was returned from the create component. So at this point, we are kind of completing our picture of the rendering engine, right? Like we said that we start with the elements. Those elements can have directives that's sitting in them, but they also can have components that's sitting in them. Well, that can be only one component that sits on a given element. But then again, component has a view because it has a template. Template has elements, and all the cycle kind of continues. So this is how we're going into the tree view of our application. Now, we are going to go through two more examples, just to kind of spice up a bit the complexity of it. So what we've been inserting so far was the kind of popover with all things hard-coded. It has the title hard-coded, positioning hard-coded, and the content hard-coded. Not very useful, right? Like I would have to write a popover window for each and every popover which I want to open, which is not very exciting. So what we want to do is to make those things dynamic, right? And you know how to do it. I would just take my component with the hard-coded stuff and replace hard-coded things with bindings. It's very simple for title, very simple for placement. Well, the things get harder with the content. Because if you've got a component that has a hole, you would use ng content, right? Like this is how we do content projection in Angular 2. So I've got this component that has a hole. And the question is like, how can I insert this thing dynamically and fill in the hole as well, right? Like how can I do this? So this is how we would like our directive to look like, is that I have a popover directive which I can give title and placement, but I can also say like, hey, fill the hole with the content of this template that I've got above, right? So this way I can use, like, I can open popovers with any content. So how can we do this? It's quite a bit of code, but it's not that complex. So first of all, what we do, we need to create a view from the content. Like from the TemplateRef. The same way as we implemented my if, this is exactly the same mechanism. I'm saying like create me embedded view for the content. Then I'm creating component, almost the same way, like this popover window component, almost as previously. But this time, you will notice this kind of last highlighted line here saying, oh, by the way, fill me the hole in this component with the nodes from the embedded view that was created from a template. All right, so I'm kind of creating the view, two views, and kind of sticking the nodes from one view into the other thing. Also, when I'm creating a component, I've got access to the instance of it, so I can easily fill in placement and title, and obviously I need to call this change detection thing. Once again, I want to make sure that I'm not confusing it. So what's going on here is that we are creating content dynamically from a template. We are dynamically creating a component, which is more or less empty. Then we move the content that we previously created to the proper place, and we fill in all the other properties, right? And then we connect the content to the change detection. Now, the ultimate challenge that we are having here is the type of components or like a view insertion that we want to do from a service. So far we've been using this very useful API, which is called ViewContainer, which once again was moving nodes to a proper place because it was anchored in an element. It was connecting to change detection. So we kind of had an easy start for dynamic component insertions. But there are use cases, and I guess this is the most prominent one, where we want to like insert DOMs, DOM nodes, or like the entire views from a service. And like implementing modals as service makes a lot of sense because there are use cases like authentication, for example. Let's say I've got the authentication service, and when the user user is not authenticated, I want to open a modal window and make sure that the user sees the some UI. So the problem is, so somehow like when we look at the widgets or things like modals, they are very similar to popovers, right? Like they've got this window, they've got the decoration, they've got some properties, and they've got dynamic content that we want to insert. The only complication here that we've got is that we cannot access ViewContainer in the services. And it makes sense because, once again, ViewContainer references were anchored in an element. So if you are in a directive and I'm injecting ViewContainer, I know on which element I am. But if I'm in a service, there's absolutely no way of knowing. Like like having access to the ViewContainer doesn't make much sense. So how can we get around this problem? And I think, like for me, this example of the modal is kind of funny because the number of discussions that was going on like different forums, like how do I implement a modal that I can use from a service? I think like countless hours were wasted on this. So 2.3 actually introduced the APIs that makes it easy. So before we see the implementation, this is the kind of API we would like to have for the modal service. It's the class, it's the injectable service where I can have an open method and I can pass a component that should act as the content for the window. Like the window of the model will wrap around the content. So what we will have to make a good use of is the new API called TemplateRef, right? And how can we make use of it? So let's repeat the process that we've been doing already. So when we want to have a modal window, we are dynamically creating the content, we are dynamically creating a window, we are putting the two things together, right? So like all the stuff you've seen before, I'm resolving component factories, I'm using component factories to create component, I'm connecting the nodes together. I'm moving the window to the proper place. Usually model window is attached directly to the body. And this is where this new API comes into place. So what the application ref has those two methods called attached view and detached view. So what attached view is allowing me to do is to say, hey, make sure that this view, this bunch of nodes, is part of the change detection loop in Angular. So every time something happens and Angular 2 runs change detection, make sure that you run change detection on this view as well, right? Because previously what we've been doing is we were kind of manually calling detect changes on the view we've created. But here we can just like, hey, application ref, here's the view, make sure that you are kind of detect changes on it. The other cool part about it is that when the view gets destroyed, all those associated structures are getting cleaned up, so you like kind of don't have to worry about the cleanup solutions. So once again, what we've been doing here, we are creating the content from a component. We are inserting the decoration, like the modal window. We are moving content, we are moving the nodes to the proper place. We are filling in the title, and we are kind of connecting things to the change detection. Right? So it's always the same process, like we're creating the views, we potentially move nodes around, and we connect to change detection. And this is how we implemented model. So let's kind of go again. We kind of went through several APIs, but those APIs are really not that important. You can look at the slides later on and see the code examples. I also linked a few planks from the presentation, so you can open them and see them live. What's important is that in the end, this whole rendering model of Angular is really simple. It all starts with elements that can react to model changes through bindings, and they can listen to events, right, from the event listeners. We can have directives that sit on elements, and then those directives can interact with the element. We've got this kind of conceptual injectors that I associated with elements, so I can inject element-specific APIs inside the directive that sits on an element. But what is really most important here is that we've got this concept of view, which is a group of nodes that don't change, that they're always through the entire life cycle of the application, a set of DOM nodes or set of elements inside one view, they always stick together. And this kind of is important for the kind of performance aspect, because Angular knows here in this view, I've got this set of nodes that will always be here. They can change their properties, but they will be never created and destroyed. So it's not like like a DOM diffing or like a tree diffing algorithm where new nodes can pop up anywhere. Like in Angular, we've got this constraint model, which in a view, we've got a given set of nodes. And then I can create those views either from a template element or from a component. In the end of the day, I'm going to get a view, which is just a bunch of nodes. And then I've got this ViewContainer ref, which allows me to insert the views I created. And this thing goes in cycles, right? Because I've got element, this element can have associated ViewContainer, can have a view, the view has elements, and it goes and goes and goes, and we've got the entire tree. And with this, that's all. Once again, I just tweeted the link to the presentation. So I know it's code heavy and you will have like a time to digest, but all the code examples are there. There are plankers in the speaker notes. So hopefully it will kind of demystify partly this part. Thank you.